Okay, thanks.
Aloha, Richard Halverson here. This is ICS321, and today is Monday, June 7th, and we are still in chapter 2. Let me share my screen. And if we look at the syllabus, we are in the last day of this chapter this week. So there's really a lot. There's quite a bit in chapter 2, so that's why I've scheduled so many classes in chapter 2. I'm going to have one later today also. If you saw your announcements, you can see that I scheduled it one now and then one later today, and I hope today I finish up chapter 2, and then Wednesday we can start with chapter 3. Chapter 3 is kind of kind of an important chapter also, and also I have to just talk about the next homework assignment after this one, or probably on Thursday. I'll do that. All right, so last time we ended up in talking about referential integrity, and I think we had just we covered primary keys pretty good, but we might not have covered referential integrity quite as well as maybe we should have. You know, this is a new textbook for me, and in the past this has been an optional. I mean, this textbook last summer, this textbook was optional. They were just starting out and didn't have as many chapters. And then in fall and spring, I kind of made it required optional, but they've continued to add to it. And as I mentioned before, I used to have a different textbook that I thought was really good. Had a lot of good videos that came along with it. But you know, this is a good textbook. It presents the material in ways that I had not seen it presented before, in a much more simple way. Part of it could be because they have to adapt the content to these tools that SciBooks offers, this sort of platform that helps students learn by doing. We learn in little chunks. You know, we're all busy these days, so if we got 15 minutes, we can come down and do some chunks and go away, and we've learned some things. And in the past, you know, this kind of material, you had to really dedicate a longer amount of time to be able to get anywhere to where, you know, the important stuff would sink in. But referential integrity has to do with when tables are linked by some key field. It's a foreign key in one table that links to a primary key in another table. For example, you have a table of departments, and each department has a manager, and so there's a manager field here, which is actually the primary key of a particular employee who is the manager of that department. So in the employee department, we have the primary key, and then in the manager in the employee table, the ID, of course, is the primary key of the employee. But then in the department table, we have this foreign key, which we're calling manager over here, and that in there is the primary key of an employee. Well, referential integrity has to do with what happens if somehow that link is broken in some way. So the link can be broken where the employee ID changes for some reason. Let's say Lisa Ellison's employee ID changes. Well, that messes up the department table, so that would be an integrity violation. Or, you know, you put a new department name with a manager. Let's say the manager doesn't even exist. I mean, that, you know, it's nothing to keep that from happening. It appears. Well, the good news is that the database has mechanisms in there to enforce rules in ways of your choice to make sure that this referential integrity violation never occurs. So so that's what this chapter talks about. And what I thought was interesting when I was reading over this chapter is it's broken it down to referential integrity can be violated in 4 ways. I've never really thought of it that way, but this is spot on. It's when the primary key is. These are the 4 ways that it can happen, and so the database provides mechanisms for you to tell it in advance what to do should somebody go in and try to change the primary key of some table of some record in some table where there's some other table that uses that as a foreign key. A foreign key is updated. A row containing a primary key is deleted. For example, what happens if Lisa Ellison is just deleted out of the table? That's like the ID changing. But so then what happens here? And then a row containing a foreign key is inserted. So, you know, some like here, this example, administration is a newly added row in department, and its manager is 202, and boom, there's no 202. The way to handle these is the data in the database. When you're creating the table, when you're setting up the referential, the link, the foreign key, when you're specifying the foreign key, you say at that time what you want to happen if one of these 4 things happen. And so you can either restrict the thing from happening. You say, sorry, you can't do this, and you just don't allow it to happen. Or you can set some key to null that if you delete or change, if you delete Lisa Ellison or you change Lisa Ellison's ID, you can say, well, okay, then if anything, any place else is referring to Lisa Ellison in a foreign key kind of way, we're just going to set that field to null. Okay, so it's like it doesn't exist anymore. So in this case, there would be no engineering manager anymore, or at least there wouldn't be one recorded here. Third way is to set it to some default, some defined default like 999 or something. The fourth thing is to cascade the change. So cascading the change means if you change Lisa Ellison's employee ID to 2540, then anything over here also changes to 2540. So the edit propagates, the change propagates. Okay, so for changes in the ID, that maybe is what you want. Regarding deleting Lisa, propagating the change would mean deleting all references to Lisa. So you would delete this department. So that's probably not what you want. So in deleting, for updating, you want to propagate. For deleting, you want to probably have the default have it be set to null or set to a default. Or maybe restrict. You say, wait a minute, don't go and delete the manager until you've assigned a new manager. In that case, you would restrict it. So anyway, that's kind of important. And when you're doing the first assignment, you actually have to set those up. And I think I just tell you what to do. I think I tell you to cascade. It just depends on the case. So this talks about that. So you should do these. I think I did some yesterday. Okay, so let's start with inner and outer joins. Okay, so joining is when you combine these two databases. You know, we've been talking about foreign keys and referential integrity. Well, let's say you wanted to have a table that's got the department name and the name of the manager. See, so well, the thing about it is the department name comes from one table, and although it's linked to the employee table, the employee name is in another table. So we want to join these two tables together, and but we only want to pick out the department name and the employee, the managers. Okay, so we only want to project in these database terms the department name and the employee name. This would be a select statement to do that. We've started talking about select statements, I think. So we want to select the department name and the employee name from these two tables together. You know, that combining these two tables together, where all combinations of these two tables, where, you know, basically this is a product. Okay, so when you join these two tables, you are taking, you know, this, you're taking this row plus this row joined with this row, and this row joined with this row, and this row joined with this row. That's 3 rows. Then 3 more with this one, this row joined with these 3, and this row joined with these 3, and this row joined with these 3. So you end up with 4 times 3 is 12 rows. But here you only want the rows where the manager field is equal to the ID field. So that eliminates all but well, so you're going to end up with this one, and this one, and sales and Maria, and marketing and Maria, and tech support is not going to be matched with anything because it's null here. So there's not going to be a combination. There is not going to be this thing. So this joins the two tables together, you know, all combinations, and then this restricts it down to just those combinations where this is matched with this. Okay, so that's obviously a join. That's pretty obvious. And this mentions that if the column names happen to be the same, let's say it's this instead, you have the ID here and ID the same name, there's advantages to having the same name. But in that case, you would have to prefix which ID you're talking about, and as you might guess, you prefix it with the table name dot the field, table name dot field. So, oh, looky here, this is the same as this. Okay, well then you really got to, oh here, oh look, this one you prefix with the table names also. All right. So any columns can be compared in the join. You know, here we're saying this is equal to this, but we could say anything is equal to anything. You know, we could say, you know, salary is equal to code, and then we're going to find people whose salaries match some code or department code, which of course is utterly stupid, but that doesn't mean that you can't do it. Okay, I mean this expression can be anything. All right, now we can be more specific with joins, because sometimes you want to keep from one table or the other. You may want to keep the records that don't match in the other table. An example that I can think of is let's say you have you know, I have a business where I sell voter data, and I match, and I have you know, I have attributes on people, like I might have their phone numbers and their email addresses, and then I have the voter file. And so I want to, so when people want to buy a voter file, they want all the voters, regardless if I have phone numbers and email addresses for them. But if I do have phone numbers and email addresses for them, then they would like that too. So then I do a join, but I want every voter, even though they don't match what I'm joining, and I got this other table that's got email addresses and phone numbers and so on. So in that case, I'm doing in how they describe it here, I'm doing what's called a left join. For joins, we define a left table and a right table, and then an inner join joins both of them, and only those matches are kept. So that's like this kind of join up here. And then there's left join, and with left join, all the left records, so all the records in the left table are kept, and those in the right table that match up are matched up. But there's going to be a lot of empty rows. There's going to be a lot of empty fields in the final table for all of the left rows that didn't have a matching right row. Right join is just the opposite, where we keep all the right rows and we only and match up the left rows, and whatever the result is, you'll have a bunch of right table fields that end up being null because there was no right matching right table row. A full join keeps all of the unmatched rows. So in these examples here, it shows an inner join, which is just where they both have to match up. So we have departments and employees, and it's only going to be engineering, sales, and marketing matched up with Lisa and Maria. And we're not going to see Sam Sneed because Sam Sneed's not a manager. And we're not going to see technical support because technical support does not have an assigned manager. So in the inner join one, we only see those three departments. In the and we only see the employees that are managers. In the full join, where we get everything, we're going to see Sam Sneed in there, and the department name associated with Sam Sneed is going to be null because there's no department where Sam's a manager. And then technical support is going to be in there, but the employee name for technical support is going to be null because there's no matching. All right, so those are that's inner and outer, and then of course this describes left and right. And so for left joining, if we're doing department and employee, from department left join employee, we're going to get all the departments, even technical support, and then we'll get the matching employee. So see, we get all the departments, even technical support, and then of course we don't see Sam over here because Sam's not. And then a right join, we get all the matching employee names, and Maria is going to be in there. We're going to see Maria twice because Maria matches once with sales and matches with marketing, and we're going to see both the sales and the marketing department. We're not going to see just one, just because there's just one Maria. So we see them both, and then we also see so we see Sam's. We do see Sam, and no department. And this alternative syntax is for the well, anyway, this alternative join syntax is just exactly this up here. So it's almost like, no, yes, it's exactly this. So kind of weird that they phrase it that way. But anyway, so here, so you should be able to go through this and tell what kind of join it is, and this is actually kind of important. I was writing databases and writing database code before I really formally learned, relational algebra. Although I took my first database class back in in the early 70s when I first started college, and it was taught by a guy from IBM. And this relational databases was invented in like 1971 by E.F. Codd. And this guy who taught this course, so I was at the University of Minnesota, he actually, he worked for IBM, and he, worked with this guy. It was just 2 years later, and there was no textbook. There was just a bunch of papers that he handed out to us. So I was intrigued by this topic back then. It seemed to just makes so much sense. And when you learn about how databases were before this, it doesn't make any sense at all. But anyway, there's other kinds of joins that you're not going to see too much, but they certainly make a lot of sense. We've been doing equijoins all the time, where we're joining on two columns where the values are equal, where the field values are equal. Now, it doesn't have to be equal. It can be like less than or equal or whatever. And those would be non-equal joins. And so let's say you wanted to join up all the potential buyers of property, and a buyer is not looking for an exact price for what their maximum price is. They're looking for anything up to the maximum price. So that would be sort of a less than thing here, where the property price is less than, it could be less than or equal to the max price here. And so here we're matching up names of people with addresses of property joined using max price and price, those two columns, but joining where price is less than max price. And so we have Lisa Ellison, where none of the properties match her max price, so that address ends up being no. Sam Snead here, I don't know if Sam Snead was a famous golfer a long time ago. And I remember the first set of golf clubs I bought when I was a kid were Sam Snead Blue Ridge golf clubs. Pretty good golf clubs. Anyway, so Sam will go all the way up to $900,000. And so a couple properties here, would fit that for Sam. So that's why you see Sam twice in these two properties. And then Jiho Chen and then Maria Rodriguez this one matches. They should have picked different names or something. It just sounds kind of not politically correct. Anyway, self joins are possible where you're joining on yourself. So let's say you have an employee manager table here, and so you have the manager of an employee, and then their manager is a field, and it's a foreign key into the same table, and it's the employee table. So we have Lisa Ellison's manager is 8820, who is Jiho Chen. And so it looks like Jiho is everybody's boss. Jiho's everybody's boss, but Jiho can't afford, has the lowest max price for a house. And another stereotype there. So anyway, that's self-joining. There's cross-joining, and all that is taking the cross product. That's like what you do way up here. That's like doing this. Well, it's just doing this basically without the where. You're just taking the cross product of all of them, and you're just listing out all of them. You're not only selecting rows where the department ID is equal to the employee ID. So that is cross-joining. And so, for example, if you've ever bought an iPhone, you usually get something like this, where there's two different models, and then there's three different memory levels, and you can have and all combinations work. So we got 2 times 3 is 6. Six of them, and they're all valid combinations. So that's when you get full tables like that.
So cross join is like a full join without the where clause. Is that right?
Yeah, I'd say that. Well, yeah, it's like any join without the where clause.
Okay.
Yeah. Yeah, you don't end up with anything null because you're just matching you know, you're just taking all combinations of the rows,
Mm.
and you aren't matching up any of the columns. There's no foreign key, you know, primary key thing there that you care about.
So probably Crossjoin isn't as popular as the other joins.
Right. Yeah. Cross joins are. I mean, I don't ever. I mean, I do cross. I mean, this is a good example of a cross join. But as far as writing an SQL statement that's a cross join, no, I've never done that. I don't know if, you know, it would be interesting to see if where's the example? Wasn't there an example code? Didn't it? I thought I saw a cross-join example of code. Oh, here. No, here.
Oh, just right. Yeah. Yeah.
I don't know if that even works. I mean, you know, I'll tell you what, it's 11:58. Let me just quickly, it's a good question. Let me go to richardh.ics321.com. I just want to go into this part. And if I just find just a couple of tables here, so I've got a P table that's got a bunch of parts, and I've got an S table that's got a bunch of that. And if I do something like select from S comma P, so that I think is a cross join, and I get, yeah, I've got there's, yeah, all combinations.
Yeah.
This is all combinations. There was five and well, here, let me just do this. Capital P. So S has got 3 and P and parts has got 5, so that's 15. And so you got 3, 2, 3, 6, 2, 3, 6. Yeah. So yeah. So this is so this cross join syntax. I don't even know if that's so from that cross join that. Let's see. I'm just going to try it. See. So let's do well, let's do this one here. Well, it doesn't matter. S cross join. Oh, it's adding something together. Well, sure. Can we add anything together? We got status of 10 and weight. Okay, so let's add weight and 12 together.
Okay.
I'm going to say S name, P name, weight plus status from S cross join P. It doesn't like something. Oh, it doesn't. I bet it doesn't like the word status. So let me. I think I can go. If I do this. Okay.
Okay.
And if I do, what does this look like? Well, seems. Yeah, I guess it worked. Well, anyway. All right. So that's cross join, but I don't know when you'd ever do it, but you can do it.
Okay. Cool. Thanks.
Okay.
That was
All
neat.
right. So let's all right. So co-joining join coding exercise. This creates. I was looking at this earlier, and I was trying to make some sense out of it. Run SQL, verify, inserts some songs and genres, performs an inner join. Run the SQL, verify the results table do not include songs of null or genre. Make the following changes. And then let's see. Well, let's just let's go through this. Oop, yeah, we might as well go. All right, let's run this. What do we get here? Okay, so we end up with this nice the codes match, I guess, and the name of the description of the type of music. Okay, the genre type. Okay. So we've got a genre and we've got a song and we've got inserting into genres, and there's a bunch of genres, and we've got songs inserting these nice songs into, and there's a genre code, it looks like. This is the songs and this is the songs, and yes, there's a genre code. Okay, so make the following changes. In the create table statement for song, rename genre code to code. All right. For song, create table for song, rename genre code just to code. Okay, I'll do that. And then modify the select statement to work with the new name. Run it and verify the result is unchanged. All right, so I got to modify the select statement. Let's see, to get there here. Song dot to genre dot.
Oh, I think it was line 14. Changing.
Line. Yeah.
Changing the.
What did I do wrong?
Line 14 that says foreign key genre code. Just
yes.
change.
Yeah. Okay. Right. That's what it says. Okay. Okay. Well. Okay. Let's see what this does. How come it said line 8 there?
I don't know. The lines were unusual, so I had a hard time on this one when I was doing it earlier. But I got it, I think.
Okay. All right. There. That's good. And then modify the select statement to perform a left join. So the select statement do a left join. Okay. So we want to do a left join here. Huh? Why? There's some songs that don't have genres or something. Oh, there's a couple of songs that don't have genres. Is that what we're getting at for this? Okay. Yeah.
Huh.
Mm-hmm.
Okay.
And so now we're gonna do a right join, and we'll end up seeing genres that aren't associated with any songs. Okay. Okay. Yep. All right.
Okay.
Crossjoin. Really? Okay. This is not very. Well, all right. That's pretty amazing. Is that what you got?
Yeah. Yeah.
All right. All right. So complete the SQL statement. I'll just do one of these. Inner and outer joins. Complete the SQL. Let's start. Okay. I want to generate this table. It looks like it's Portland.
see. So
What?
select.
Why would it be? I don't.
Oh, is it select college dot? No, wait, no.
No, it's just
Oh,
this.
select city and state code, right? No, let's see.
Yeah, but all it is I mean, it looks like it's just the location table. Well, okay, location, right? I mean, this table, the result table looks exactly like the location table. Am I missing something?
Let's see.
Where? I guess I could do location city equals. It's kind of dumb though.
I think. Oh, sorry.
No, go ahead. What?
Oh, no, I was gonna say that I think yeah, the top one, they wanted that to be like the titles of the titles of the columns for the result table or something.
Yeah, well, I don't, well, I mean, it's ambiguous. If I take these out of there, it's ambiguous. So I don't know. It's just, well, sure. All right, if that's order and part number, part name, order. Okay, so now this is different. See, this is not just, we're still doing number one, but this is not a single table. I mean, this is part number and part name come from here, and then order code comes from over here. So yeah, we got to join the tables. Before we didn't have to join the tables. We could just display out the location table, and was exactly that's why that's kind of what I was getting at before. But
yeah, okay.
So are we supposed to only put, is it the same kind of thing where I'm just supposed to put part number here?
Yeah, I think so. Part number, part name, order code. And then where
order part
or
equals part.
No. I think they have the part first.
Oh, part first? Oh.
Yeah.
All right. No, that completely shouldn't matter.
Yeah.
I'm gonna try it. Okay.
Okay.
If you're right, I'm gonna pound myself with a hand.
Right. Oh, okay. Okay. No, I was just wondering if they.
Okay.
Okay.
Okay. Well, no, that's okay. So, all right. So I'm not gonna do any more, but so you out there in video recording land, you sort of get the idea here.
Yeah.
Right.
Okay. Cool.
This is view tables. How far was I planning on going today? View tables. Oh yeah, in normal. Okay. Okay, let's keep going here. View tables. All right. These are just views. We're creating views. And a view is just a stored SQL statement. If you they talk about being able to use views like tables. So in the place of an SQL statement, let me find an SQL statement. Here's an SQL statement. This can be a view. This doesn't have to be a raw, I'll call it a raw table or a base table. I think they call it a base table. If this can be an SQL statement, then this, I mean, if a view is an SQL statement, and you can use a view here, it makes sense. You can also use an SQL statement there. I mean, you can use anything that produces anything that looks like a table. Okay. In fact, that's what's great about SQL is that it's got this property called closure, where you can do SQL, where you can replace this with another SQL statement that produces something that looks like a table, and then you treat it just like a table. You can join column names and all that kind of stuff. Here, either here or here, you can put something that produces a single value, some select statement, some complex select statement that results in a single value. Then you can put that here, where you have something equaling that single value. But anyway, a view is a pretty common thing to use, and I'm trying to remember if I asked you that. And also, I wanted to. Somebody asked in a forum, and I don't think I'm going to get to this hour, but the next hour, I'll respond to a assignment question that somebody asked, and so I'll get to that. It's on the normalized test, which is assignment 2. But I think this might be a related type of question. Okay, so the problem here that this gracious student who that offered up his error, this is great because probably 10 other people are going to have this run into the same problem, and so if you look at this, you're saving yourself time. This is creating a view. View original is the assignment is to create a view that produces the original back again. And so it's a simple thing that you do. And so I will do that. In fact, it's 12:14. I might go and do that now, I might do it in the next 15 minutes, which is how much more time we have. But anyway, so that's views. And basically you're just memorializing a select statement and giving it a name. Okay, you create this now. So what's great about a view is that when these base tables can change, and then the view changes right along with it. So when the base tables are updated, the view is like automatically updated because it's actually a virtual table. It's a SQL statement which creates something that looks like a table and is treated like a table. Now, advantages of views are obvious. Saving complex queries is a really good reason. And also, the SQL, the database is going to optimize your view query. If you go back and you look at your query after, you put it in there all nice and pretty and everything, and then you store it and you go back and look at it, it's all different because they've optimized it. The database manager the database machine has optimized it. Now this chapter talks about updating views. It talks about where, how a view can be treated like a table, but really it's just a table for select purposes. It's just for the from select purposes. But you can also try to do an update to it where you're treating the view actually like a table and you want to update some fields in the table. Well, apparently you can do that. I've never even thought to do that. I thought to do that, but I thought, geez, you don't want to do that because you don't know what's going to happen. A view is a construction of possibly several tables, and you're renaming stuff, and there's the ambiguity going back in the other direction, and so who knows what you're doing. You've got aggregate values in there and so on, and so what are you doing when you're updating a view? Well, it turns out that for some there's reasons for it, and you can read this, and it turns out that if your database management system allows that, I personally don't know if MySQL allows it, but if it does allow it, then you can run into problems because you might do an update where you're inserting some data into a table and it's not going to appear in the view because of the where clause of the view. You know, the where clause of the view keeps it from being viewed. Like let's say your where clause says you only want to see people with salaries over $100,000, and you use your view to insert somebody whose salary is $90,000, and then you try to look at it from the view, and you don't see it in there. What's going on? It didn't work. Well, it may have worked, but you wouldn't know because your view is excluding people from. So this talks about how if your database management system does allow that and you want to do that, there's a check option clause. You can put with check option, and it won't let you insert anything into a table, a base table that would not be viewable by your view. So I guess that's a convenient thing to use if you're going to play with fire like that. All right, so it's good to learn about views. There's a views in our assignment. And so I'm going to go check out this assignment 8.2. Let me just look at see what the assignment is. I hope I get this right. Assignment. And it's creating a view. So I might as well do this now. Okay, so what's 2.2? Okay, so we have this table here, and we're supposed to reduce this to we're supposed to decompose it into a set of BCNF tables, and we're going to learn what BCNF tables are in the next section here. So why don't I discuss the next section here before I talk about this? But basically what this problem is you're given a table like this, and you're supposed to decompose it into a bunch of smaller tables, namely ACIS. You're supposed to decompose it into, this is the original table. It's like that. Yes, DF name. And you're supposed to decompose this table into an employee table and an employee hours table and a project table. Oh, and a SIP city table. And then so this is the original table. And then you're supposed to create a view, which is this thing, view original. And when you look at view original, it produces it's this great big select statement which joins employee and employee hours and project and zip scheme, joins them together into something that looks just like original. And that's what the problem is. So by the way, if you look at there's a way I can look at, somehow I look at view original structure. Somehow I can look at what it is. I know how I look at what it is. I import it. I export it. I'm just going to do custom, and I'm going to view as text. And let's see if this works. Okay, here it is. See, this is just a great big select statement. But that's not how you write it. I mean, this is what it gets reduced to. So we're joining stuff, see? But I think, let me take a look at these two. I think, what happens if you go like this? Okay, it's we want them to be in this order. So to make sure it's in that order, I'm just gonna, how do I grab I want to grab export. Custom Continuous text. Here, I want it to be in this order. Okay, so watch this. I'm going to copy this. And in fact, I'm going to do something else here. I'm going to just in case I want to come back to this, I'm going to copy this whole thing out here. Copy, and I'm going to paste it right here, just in case I want to refer to it later. But what I really want to do is I want this is the order that I want to display out the columns. So I'm going to copy this, and I'm going to go over and do this. This should work. I think this should work. So let me go here, and if I'm careful and I made all the column names exactly the same, well, let's see. What happens if I go start with employee? Select this from employee natural join EP hours, natural join project, natural join zip city. What is this going to do? Is that it? What is okay, I gotta save this. Save it. So I might want to order it now. What's the original? Original is 15 of them. They're ordered like that. And the first ordered by EID, and then what's the next order? No, and then they're ordered by PID, it looks like. Yes, EID, then PID. Okay, I'm gonna save this. Let me just put this down here. And so I'm gonna go back to wherever. I'm gonna do this again. Oops. Oh no. Oh no, did I not? I didn't save it. Ugh. I didn't save it. What happened to it? Oh, did I use it to clip it? Oh, shoot. Okay, try to do it again. Copy this. Select this from employee natural join EP hours, natural join project, natural join zip city. Now, you're probably wondering what natural join is. Well, what natural join is it's join. It's join, and if the column names are the same, if all the column names are matched up, you match up all the EIDs together, and if you've kept the column names the same, then you don't have to use the join on column name equals column name. You can leave that part out. You can just say natural join, and it's going to look and find the column names are the same and join on those. So this does that, and it sort of also suggests that order doesn't really matter. But anyway, so I've got this, and then I'm going to order by, I don't know if this is going to work. EID. See, EID is in several places. PID. So we might have a problem here because of ambiguity. Let's see. No, we didn't. All right, so we did not have a problem. So this is the result, and what does the snipping tool look like? How do you? It's too big. All right, it looks the same to me. $30.25 tax preparation. Okay, so anyway, to turn this into a view, You just say view. Create view name. Okay, create view name as. Might need that column. So create view name as that. Okay, so it's it is create view, and I'm going to call it view original 2 as, I like all caps, that. Okay, so create view, and this is the name of it. I think this will work. Go. Ooh, it'll work. Employee. Oh no, this one. Views. Oh, it is here. It didn't show up over here, but it showed up right here. View original 2. So now when I click on browse, lo and behold, there's my table. So anyway, so that, and so I think that should work for this forum question.
Oh, cool. Thank you.
Okay, so I'll tell you what, so this is the end of the time. So I'm gonna end the class now, and I'm gonna go and I'm gonna see if this does answer the question, and I'll answer this post here. You all can look at the post, and then next time, later today, I will come back and I'll start with normal forms. I guess we didn't really cover normal forms, and I hopefully we'll get through normal forms and we'll at least get a good start on this relational algebra section. We might not have to spend too much time on this, but we do have to, we should go over this because it's kind of the science of it. So,
Okay.
all right.
Thank you so much.
Okay.
See you. Bye. Thanks.
Bye.